Hi to all. I am Dr. N. Lakshmi Priya of Shriram Engineering College. Today we will see about the basic laws of electrical machines. First we will see the fundamental principle. Electrical machines works on the principle of Faraday's law of electromagnetic inductions. It states that magnitude of induced EMF of in a circuit is directly proportional to the rate of change of magnetic flux through that circuit. We will see how does this work. When the bar magnet shown below is moved towards the coil, the needle of the ammeter will deflect from its zero position. When the magnet stops, the needle returns back to zero. When the same bar magnet shown below is moved away from the coil, the needle of the ammeter will deflect in the opposite direction with respect to its previous position. Likewise, in the next case, if the magnet is kept stationary, the coil is moving towards or away from the magnet, the needle will deflect in either directions. Moving a coil in the magnetic field induces a voltage when the induced voltage is being proportional to speed or velocity. Faraday's law holds true there must be a relative motion or movement between the coil and the field and either. Next, we will see about the Faraday's first law. When a conductor is put in a changing magnetic field, an induced EMF is produced, and if the conductor used is a closed means, then an induced current flows through it. The next law is Faraday's second law. Faraday's second law states that the magnitude of induced EMF is directly proportional to the rate of change of magnetic flux. The mathematical formula is expressed by E is equal to minus n d phi by dt, where n represents the number of turns of the coil. The induced voltage is proportional to the number of turns per coils. If there are more turns that means the more voltage is created. And the second factor is E is proportional to the magnetic flux and change in magnetic flux. That is the rate of change of magnetic flux with respect to time. The induced voltage is affected by changes in the magnetic field. This can be accomplished by rotating the magnetic field around the conductor or by rotating the conductor inside the magnetic field. The former is called as statically induced EMF and the latter is called as dynamically induced EMF. The negative sign indicates that as per the Lenz's law, the induced EMF opposes the supply voltage. Next, we will see about the Fleming's right hand rule. It is used to determine the direction of induced current in a conductor moving within a magnetic field, which is primarily used for understanding of electrical generators. If you are stretching your three fingers of your right hand, that is your thumb, forefinger, and your middle finger are mutually perpendicular to each other, the thumb represents the force, the forefinger represents the magnetic field, the middle finger represents the voltage and current. Next, we will say about the Fleming's left hand rule. It is used to determine the direction of force acting on a current carrying conductor in a magnetic field, which is essential for understanding the concept of electrical motors. Likewise, if you are keeping your three fingers of your left hand, that is your thumb and forefinger and middle finger are stretched, which are mutually perpendicular to each other. The thumb represents the force, the forefinger represents the magnetic field, and middle finger represents the current. Usually, the students is having a confusion among these two rules, which one is applicable for generator and which one is applicable for motor. So for better understanding, I will give this some keyword. That is, in the sentence Fleming's right hand rule, there are two or is used. That is in the word right and in the word rule. Similarly, in the word generator, we are utilizing the two or. So Fleming's right hand rule is applicable for the generator. And in the sentence Fleming's left hand rule, only one or is utilized for the word rule. Similarly, in the word motor, only one R is used. So Fleming's left hand rule is applicable for motor. Next, we will see about the Maxwell's right hand thumb rule. The right hand thumb rule is used to determine the direction of the magnetic field around a current carrying conductor. If you are holding the current carrying conductor with your fingers, the thumb and keeping the thumb up, the thumb represents the direction of the current and your curled finger represents the direction of the magnetic field lines. Next, we will see about the right hand corkscrew rule. It is used to determine the direction of magnetic field. The rotation of the screw shows the magnetic field lines and the screw tooth shows the direction of current. Thank you to all.